So what we've been tasked with, this young engineer with the company has been tasked with migrating a PLC5. So we actually have a PLC5. And why we chose this is Rockwell estimates there's still 100,000 PLC5s in operation in the United States. They sold about 500,000 of them in the product life cycle. There's still about 100,000 of these still working. So what we're going to do, we've been tasked to modernize, not just migrate from old to new, but also modernize. So we've got a main rack and we've got a remote rack. And that's the code I wrote for that project. So let me get you. So the question is, we're going to actually run the migration tool. So what we're going to do is we're going to take the raw code and do a conversion on it. And this is the tool we use. And we're going to ask this gentleman to actually run the tool. So I'm going to ask you to go File, and go New Project. And I'm going to ask you to type in under Name MME underscore PLC5. PLC5. Okay? And say, OK. We're going to create a brand new project. And the whole fate of our seminar is on you, sir. So go to Toolbox, top left. It's on the left there. And we're going to use a menu, and we're going to do RSLogix import. We're going to bring in that file type I spoke about. So go ahead and click RSLogix import. And in the middle, you see the ellipse. I'll show you. Yeah, that's an ellipse. And I'm going to take you to the folder where it's at, just to save time. And what I did before today happened, I went ahead and took my project and did a save as, and there's my PC5 file. So highlight that file, that one, say Open. And then I want you to hit, now you'll notice something, it picked the file in for me, it picked the library files. So I've got all my library files, I've got all my symbol files. It pulls those all in for me. I'm going to ask you to hit Execute. And what we're going to see on the left, the area in the middle of the tool is the work area. It's telling you what the tool is doing. The area on the left is a model of this PLC5. And as Keith pointed out, it's going to show the I/O, it's going to show the programs that are in it, and it's going to show all of the data. So the data is all the registers. Okay? So let's go to Toolbox. I'm going to do that in a minute. Go to Toolbox. Let's go. Now we want to migrate this. We need a schematic view of that Rockwell structure for I/O and the code. So I'm going to ask you to highlight RSLogix to schematic. And it already identified what processor it was. It knew what it was from that library file. And so it's going to use some certain rules to create the model. I want you to hit Execute for me in the middle. And now on the right-hand side of the tool, we're going to see a schematic model of the Allen Bradley. And so it's already built the model. So let's go into the tool a little. Let's go in and explore a little bit. And I'm going to drive for just a second, just to make it a little faster. And it creates a model of the modules, the two racks. And it saw that I had LAD 2 and LAD 3 in my project, which I do. And I can drill in further. We'll do that in just a minute. It's now going to go in and show all of my register files. And since this system has analog I/O, guess what I have? I have all kinds of N registers. I have block transfer registers. It created all those when I wrote the program. And it recognizes all of those. So I'm going to ask you a favor. Go over to the right and go into data blocks. Actually, go into functions for me. Hit the plus sign. Now, here's one of the rules that you'll find out when we go through the tool. In the PLC5, it does everything in the continuous program called LAD 2. The rules the tool uses are as follows. Every time it sees a routine, it creates a function call. Same concept. So you'll notice on the left, we had LAD 2 and LAD 3. On the right, we have function call 123, which is the equivalent of LAD 2. And we have function call 124, which is the equivalent of LAD 3. So not only does it maintain the structure, you actually go in and it will recreate all of the rungs and recreate all of the instructions. Its goal is to do an apples-to-apples conversion. So now let's go into tag tables. And you'll notice something. All of the I/O is in that tag table. So the I/Os that were on the left show up in the I/O table on the right. If you can go into data blocks for me, at the top, keep going, hit that plus sign. There are my N7 and T4 and my other registers. So I've created a data model. I've went from registers to tags. In the Siemens world, everything in a tag environment is a data block. Data blocks are also used to make things retentive. In Allen Bradley, all memory is retentive. In Siemens, you decide what's retentive and what isn't. We assume you want everything retentive, so we're going to build all the data blocks for you. So we take care of all of the structure and all of the necessary code and all of the data blocks for you. They're all done. So far, so good? Now, there's one other thing we talk about. When we do this code conversion, we actually ask to come out to your facility and explain what I've just explained now, so you can understand the before and the after. One of the things we learn when we use the tool is any register that was in the original project that doesn't show up in the actual code doesn't get converted, because we want the converted code to be as efficient as possible. So you'll notice some registers on the left that don't show up in the data blocks on the right. There is no B3 because I didn't use it in the program, so it didn't convert it. So let's go back to the toolbox on the left, and please ask questions if you have any. And I'm going to ask you to do TIA compile. Scroll down, hit the compile. Now we've just built the model. Now we need to actually create the project. So let's go ahead and execute. Now, how many in this room do compiles when they write their programs and download it to the processor? This is the part we always get nervous. Is the compile actually going to work? So what it's doing for all of my registers, it's compiling the data blocks. For all of my routines, it's creating all the function calls. We've been doing a number of these since the tool became available, and half of the migrations and modernizations we've done have been control and compact logics. That surprised us a little bit. We were expecting more PLC5s. So over half are logics. Of the remaining half, about 2/3 are PLC5s, and the remaining thirds are micrologics and slicks. So if I'm in the logics environment, there's a couple extra things that happen on the right in the tool. One, add-on instructions get converted to function blocks. And every time we have a function block, it creates the associated data block. Two go hand in hand. In logics, I have data types, UDTs. We create the data types on the right. So that would be an extra thing you would see if we were converting a logics program. And so what we always want to see is at the bottom, which was we created 9 data blocks, 3 function calls, and how many invalid memory references? 0, which is a good thing.